Let's say you have an interesting project that requires temperature measurements. So the first thing that you obviously do is to search for the most decent probe for that. In this video, we will figure out which one exactly is the best among the others. This video is sponsored by NextPCB. NextPCB is a very large and famous factory in Shenzhen that produces all sorts and kinds of PCBs. Also, they have a capability to ship it to any country around the world. Their service is awesome. The quality of the PCB is too high, so you must go on their website and place your first order for free. Before we start, you have to know what RTD stands for. Basically, it means for short, resistance temperature detector. Why we call it resistance? Because these guys act like a potentiometer when there is a temperature differences. And that means delta R is equal to delta T, which also means that the function is more or less linear. After that, I grabbed my multimeter and I set it to 200 ohms. Then, I measured the resistance of the RTD at the ambient temperature, which gave me 115.6 ohms. Next, I created a voltage divider, in which I set R1 to 10K, and R2 will be the variable resistance of the RTD, in my case the Pt100. I applied 5 volts to the circuit and I got 0.58 volts at the output, which was also confirmed by the theoretical formula. Okay, now let's build the thermometer that goes from 0 to 150 degrees. This table here shows approximately how much the resistance of the Pt100 will be at both 0 and 150 degrees. Since now we are set, we start calculating the output voltage of the voltage divider. At first 0 degrees Celsius. That gave me a 49.5 millivolts. And next I calculated the output voltage at the temperature of 150 degrees, which also gave me a 77 millivolts. Now, for measuring out values, we will need an ADC. You might say, okay, let's use the ADC of the Arduino, which measures voltage from 0 to 5 volts, right? Okay, we start by doing an impedance adaptation, which makes the effect of loading so low that will not affect your measurements. Okay? But now, at 0 degrees, the output voltage is 49 millivolts, isn't it? So it's not an absolute zero. We have to get rid of it. This is what we call a differential opamp setup. It basically subtracts the voltage V2, which is the voltage measured from the Pt100, out of a reference voltage V1 of 49 millivolts, and which you will set by a voltage divider. Finally, we need some amplification, since the voltages are so small to get measured. And when things are getting to get too complicated, I searched online for a solution to this madness, and I came up with this integrated circuit, the MAX31865 RTD converter, that can measure precisely the temperature from the Pt100, but also a Pt1000 with 3 to 4 wires. And by installing the adafruit MAX31865 library and connecting the shield pin to your Arduino, you can now have a decent temperature measurements embedded on your system. And like that, you created your own thermometer. There's still a lot of things that we didn't cover in this video, such as the slope and the response of the Pt100. Up till now, I hope you learned something useful from my video. Like it, share it, and subscribe it. That would be awesome from you. I see you in my next videos, guys.